Thank you for coming and sitting here during your lunch hour. I hope everybody had a chance to actually eat something before coming in here, or brought it, even better. As already stated, I'll be discussing kind of the two different parallel tracks for trying to get development teams to work functionally with security teams. And I am obviously of the mind, as a former developer, that the carrot is the better approach, and more importantly, that generally speaking, introducing development teams into the security process to ensure that they are harmoniously operationalized, as opposed to kind of the stick method, which is more of a retroactive, why did you do that type response to security results, is not only going to drive better results, but also probably going to get developers to answer your phone calls beyond the first call. So needed a slide with my face on it, so we have a slide with my face on it. Most important thing to know about me, I am a former developer, former product owner, former lots of things in terms of developing, consulting, and deploying solutions, mostly those that are automated to do process generation or security at Fortune 500 organizations. And currently, I run customer success and am part of the product arm at Arnica, which is a CI/CD security solution, which I will talk about as little as possible throughout this presentation, because that's not why you're here. But the most important thing to know about me is I am strategically placed to both feel all of the wins and losses of our customers, so I feel all of these challenges innately on a day-to-day basis, and am a huge part of trying to answer them, which I guess makes me well positioned to give this conversation. Now, generally speaking, as kind of an introduction, you're probably very much aware of traditional security processes, those that are either trying to figure out where risks exist in legacy systems, or trying to keep up with where risks are introduced in new code. There are a lot of different ways to go about this, but generally speaking, all of the historical methods create a friction point between development teams and security teams. Not uncommon to have them eat at two different lunch tables, and the biggest reasons for these are that, generally speaking, they have two different goals within an organization, and it's very difficult to get them to function harmoniously without the improper incentives in place. Now, the biggest part of this problem is that while they both function almost entirely within the SDLC as well as the deployment process, they end up in the principal's office for two completely different reasons. No developer has ever been told they're not going to get a promotion because they introduced a security risk. But it's very likely that they're probably not going to get their own team if they miss deadlines on a regular basis because they're fixing security risks. So there's a very unfortunate kind of friction point here. And there's many very, very visible reasons for this. But one of the biggest ones is, again, in enterprise software, these teams have the same goal, but with very different KPIs. So development teams, generally speaking, get to build cool stuff. That's what they want to do. That is what they are goaled on. And they have to do it quickly, or they get themselves in trouble. Security teams, well, they want to ensure that that cool stuff is sustainable and that customers don't get in trouble for using it on their side or internally. But their KPIs differ drastically. As I mentioned, development velocity and speedy deployment is the #1 thing that development teams are goaled on. And on the security side, it's thorough coverage, often measured in the number of scans before deployment or scan volume and risk remediation. We can already tell why these two KPIs are completely opposite of one another. Now, when it comes to departmental goals, obviously in development world, we hear a lot about agility, iterative changes, things that terrify security teams because they like process, gates, audit, GRC recovery, right? On the avoid at all cost side, we have developers not wanting impediments, not wanting to be slowed down, and security doesn't want untested changes, immediate emergency fix to production environments, and the like. Again, from their two different sides of the table, completely reasonable assertions. The problem is, when things are said, they hear two completely different things. When developers say, we want speedy delivery, well, security hears risky deployments. When developers say, we are agile and iterative, well, security hears, oh great, we have technical complexity and unknown risk in every single one of our deployments. When security says, hey, we're going to send you alerts when there are risks, developers rightfully hear, hey, cool, noise and alert fatigue in my development process. And when security says we're going to prioritize security risks, developers hear, I'm not getting anything out to my customers. I'm going to be context switching constantly, and I'm going to be seeing deployment delays on a regular basis. So there is actually behind this a pretty stark reality. Bonus points if you can see the Game of Thrones reference here. But the general premise here is that if you are running a security program, or if you are running a development team that interacts with security programs, there is a fact that we cannot escape, and that is developers need to be a part of the process. They need to be a part of the process not just at the end in fixing risks, but in actually voicing which ones are risks, identifying what is reachable, identifying which resolutions are proper and adequate to get development completed, and without that, we're just not going to make any progress. So let's talk about why we don't make progress without that. The traditional siloed response to security, which again, as I've mentioned, typically is conducted after a build process. Maybe you're scanning an image. Perhaps you're even doing this in runtime or in production, which means developers haven't touched it in a while. You're going to run into problems where the release process is where testing happens. Well, developers have done a lot of iterations of testing before the release process, and they are, as far as they're concerned, done with that code. How many people have logged into Jira, Atlassian, GitHub, Bitbucket, GitLab, and found a ticket that said done by a developer, and it's in dev? It's not even in production yet. It might not even be in a PR yet, but the ticket is done. That's because done means something different to these two different teams. So when developers have finished a feature, it works, it completes its unit test, and locally, anyway, there are no bugs, they mark it as done, and they're right. The problem is it then goes through a QA process, a security governance process, and then gets kicked back to them. And their done work has a grade on it that's written in red, and they have to change things. Retroactively assigning these mitigations, unfortunately, at build time or in production, drastically increases the time to remediation, the amount of refactoring necessary to resolve the problem, and gets in developers' way. Rules and policies generated in a vacuum mean half of these things that get sent back to developers don't actually need fixing to begin with, because it might not make sense. Maybe, based on the testing that was done in deployment, they found a risk, but the entire product is going to be deployed on-prem, perhaps behind a control gate, and it's actually not exploitable. The developer could have told you that if you just asked them. Chastisement and retroactive correction, this is kind of the epitome of the stick, so to speak. I think we can all agree doesn't work anyway. Anybody who's ever tried to take a stuffed animal away from a child while making their way through Stop and Shop knows exactly how that operates. But if we do it with developers, we just create bad relationships. And lastly, listing risks per product and defining efforts based on misses is a really good way to get both product owners and leaders on development teams to feel like you are inserting yourself in a process that they own in the organization. The way that we traditionally attempt to get around this is by putting tools on either side of the development process. So we either give development teams an IDE plugin, which half of them turn off. The other half see alerts and say, cool, maybe I'll work on that if security tells me I need to later. And the portion of the group that is very security conscious, because let's be honest, developers are actually interested in writing secure code. It's just not their day-to-day responsibility. Probably can't keep up with all of the alerts that they're seeing in the IDE because they're incredibly noisy. And what they're really concerned with is code quality results, because they want their code to work, because that is how they get gold. For this reason, adoption of IDE plugins is typically not very high, and resolution of risks that are identified in IDE plugins doesn't tend to meet with expectations. When we apply gates and visibility into PRs, into pipelines, first of all, they are a nightmare to maintain, which means you've now asked DevOps to put a security protocol in place in their product that they don't want to begin with, and they need to maintain it throughout the life of the product. And beyond that, you're also already in the PR process. Developers have finished working on this code as far as they're concerned. As we discussed earlier, once it's in dev, it's done. Anything after that carries the same risk. So it's effectively, from the development team's perspective, too late, disruptive, and fatiguing. Now, I thought with AI, which we're all terrified is going to take over our jobs in the next 10 years, and I'm no longer terrified because after 30 minutes of trying to get an image of a person holding a stick and a carrot, this is as good as it did. So we'll all collectively breathe a little sigh of relief there. I don't think we're in trouble just yet. Generally speaking, I'd like to just stop for a moment and agree on the definition of the carrot and stick, not because we necessarily have to, but because, well, actually we do have to. So in the premise of security, the carrot is not necessarily a bribe. The carrot is not giving developers dollars or Amazon gift cards or a coffee every time they do something right. The carrot is quite literally accepting that they are a part of the security process and crediting them with the efforts that they are conducting within the security process. The stick, on the other hand, is just telling them every time they don't, which typically is not paired with notice beforehand. It's typically just, I'm not going to say anything until QA and risk reduction look at the findings, and then we'll send them a nice big spreadsheet with 600 risks, many of which predate their even joining the organization, and we'll ask them to deal with crap they have no idea got in there in legacy code. I'm going to suggest a few changes to the way that this model operates. First and foremost, I'm going to suggest early detection. And when I say early detection, I don't mean locally on an IDE disconnected from security teams. I mean a process in which you are able to provide feedback from the developer in their feature branch, which is actually connected to the home base, if you will, for security teams. Now, another absolute key requirement here is while it might not be what security teams are necessarily gauged on, your success as a security team typically is how many risks exist in production, what severity they are, things like time to remediation, how quickly you can swing the stick, basically, and get developers to fix those things, not how many alerts went out. This is a metric that nobody bothers to capture. It is probably the most important to developers because every alert they didn't need to take action on, they did read, and it did distract them from whatever they were doing. So actually putting in place metrics and measurements for how much noise exists and improving the response times is super critical, and agreeing on those with developers is equally critical. Providing ownership to the development team to increase engagement. Now this sounds like, hey, that's a really lofty and interesting idea. They don't want ownership. They do. I promise you, they want to understand and own what is fixed in the product based on risks. They don't want to sit there and go back and forth over, which OWASP top 10 rule is the best or exactly how things should be oriented in terms of policy governance, but they care an awful lot when they start getting notifications that don't make sense in the context of their product. I'll give you a really good anecdotal experience example here. I'm sure that we're all familiar with unsanitized strings in code. Generally speaking, there is a very well understood and very well accepted package out there in the open source community referred to as DOM Purify. It has a function within it called sanitize that just about everybody agrees is an appropriate way to mitigate unsanitized strings within code. However, many organizations will actually bury DOM Purify into an internal function that calls many different purification or sanitization functions so that they don't need to pick the right one in every place. They simply call internal domain _ purify, and that import brings in everything that they have told the development team, here is your suite of security toolings. Most situations, SAST rules are not going to tell you that that's an acceptable mitigation. They're going to continue to flag it over and over again because they're looking for DOM Purify. Makes no sense whatsoever, right? A development team could have told you that the first time they got the alert. They could have said this makes absolutely no sense, flagged it, and immediately, if you're paying attention, we can customize the SAST rule and resolve the problem right away. If it's always retroactive, the feedback loop is not there. Customization and guidance is obviously tied to that directly, but more important, resolution as well. If there is a specific way that the development team can resolve a finding and a specific way that the security team needs the resolution to be conducted, working together to make that viable in the context of each product is critical to get engineering teams to respond, or they're reading the risk differently than the security team is. And lastly, and this is the most important one because it's where the carrot comes in, recognizing when developers take action specifically to mitigate risks and not calling out their mistakes when they're made. Now, By doing this, we have a couple of really big kind of paradigm shifts within the process. The old process we discussed has a problem with context switching and development velocity. We're interrupting them when they're working on feature number 5 to ask them to change things in feature number 1. Obviously, this is based on late risk identification, and of course, early detection is going to resolve this to a large degree. But from a security perspective, you should be very interested in early detection as well, because it not only reduces the number of SLAs you need to be monitoring if risks are fixed before production and not identified during QA processes, but it also drastically reduces the mean time to remediation. On average, estimates in analyses state that it's around 271 days for your average risk to be in production to get resolved. And GitLab actually recently published a very large and extensive report on findings resolved within GitLab and identified that those that make it to production before they are acted on by development teams can be 20 times more costly for remediation than those that are resolved either during design or during early development process. Those are pretty important things to enterprises, and obviously KPIs that the security team is actually going to be answerable to. Unfortunately, in the old process, post-development scans result in low impact, whether you're turning IDEs off or depending on DevOps to set up pipelines in your CI/CD process. What we've identified through our customer onboardings as well as our internal research is that roughly 46% of all code goes unscanned in pipeline scans. They just don't have the pipeline configured properly, or it's only on specific assets that are being scanned. Because of the actual lift, technical implication, and cost of monitoring all of your source code, enterprises tend to have to make a decision. Where are we going to put our teams? And security teams are not big teams. Anybody work for a security team that's the biggest team in their organization? Yeah, you're not getting extra people because they added a repo, right? So unfortunately, we need to determine where we're going to spend our time, and often this means actually reducing the amount of coverage. And lastly, improving the developer's empowerment has a huge impact on these things. Now, I'm going to get into a little bit of the actual deployment methodology for how this can operate. Generally speaking, there are many points in the CI/CD process between the IDE and production that are giving, or I should say, are appropriate opportunities for these scans. So pre-commit webhooks, post-commit webhooks, and webhooks directly within source code management platforms offer you the opportunity to catch pushed code and scan diffs in real time when developers are developing. Our personal approach uses the SCM webhook and actually scans every diff in every code push and notifies developers directly through chat ops. We go where the developer lives, comment in PRs, add status checks to pull requests, notify them in Slack, even if you also pay for Teams. Sorry, Microsoft. I know we're in the Microsoft building. Developers are probably using both, right? Or Discord these days. So deliver the context and the notification with as much information possible to reduce remediation effort and help them fix it. Don't just tell them that a package has a version in it that needs to be updated. Let them know which version they need to move to. Ideally, the lowest semantic version change so that they're not refactoring an entire product to get a medium severity risk out of it. Empower the developer to keep developing by giving them the ability to do this quickly. We are going to talk about AI for just a moment because there are applications where it's incredibly useful. If your organization has Azure AI or OpenAI integrations and you're terrified developers are just asking it, give me this API call, and then copy and pasting it, you're probably right, I hate to say it, but there are actually implementations for this that are incredibly useful, namely using your code snippet from the risk to actually rewrite a code recommendation that doesn't come directly from W3 schools. Here's where it gets really, really critical and really, really impactful. When you start leveraging context from the developer's workflow instead of from a deployment workflow, we can actually start to use context from Git to turn Git blame into a good thing. In this case, kind of coined Git fame up there, because here we're actually looking at the efforts that developers are making to meet security. Not only do we have the ability here to identify security champions who will certainly be impactful in your org, but also they're going to lead the charge for developers to act on security risks because they'll be able to tell the story of how they got their feature in and never ended up having to revise the code 6 months later while the rest of the teams are rewriting it. Of course, we can get status checks directly into the SCM to ensure that hard gates, which must be applied for security purposes, exist. But the importance here is it's their third warning, not their first. And by adding the right context to every finding, and maybe more importantly, the right contacts, we can actually create a training environment that actually improves the developer workflow. As a junior developer receiving a risk I've never seen before, it's incredibly helpful for me to know who's also developing as a senior developer in that repo, in that language, and maybe even which of them have resolved this particular risk type in that product historically. I know exactly who to go to. It's getting fixed that day. Giving the developers the ability to dismiss everywhere you alert them is also critical. Not because we want them to wipe things off the board or just grab the big eraser and say that's not real, but because we want the feedback from development teams, which matters most. Giving them the ability to dismiss, ideally with a review required when things are critical, but actually explain why they believe this is a dismissible risk is super critical, not only so that they don't get blocked, but also so that we can run through iterative changes for the SAST rules and output from the solution. Collecting this feedback and acting on it should be one of the biggest priorities of security teams if they want to work side by side with developers instead of siloed. So speaking to why I think this is a great idea, it's not just pontificating. It's a little bit of that, but there's also numbers behind this. So I mentioned that I have a history of rolling out enterprise-level automation to change processes and security at many organizations. For the past 4 years, I've been doing it in the security realm, specifically within CI/CD pipelines. And for those customers who have done this and have shifted to these kind of protocols, the numbers are pretty drastic. First of all, they're measurable. And that's rare within the security realm, because unfortunately, when everything is done post-prod, you think of development as a black box that you don't know what's happening. But when you start to actually track risks across feature branches, track risks across parts of the CI/CD process, you can tell where things get remediated and in what timetable. You stop talking about SLA dates, and you start talking about 3 different mean time to remediation. Mean time to remediation in feature, mean time to remediation in development, and mean time to remediation for those few risks that actually make it to production. I say few because we found developers actually love being given information and not warnings, and 78% of all risks that go out in ChatOps alerts to developers using our solution actually address it before they even create a PR. That's astounding. That means the reviewer didn't see it, security didn't see it, QA didn't see it, it never got added to your list of SLAs you're managing for GRC and audit. That's a huge time savings. For those that do make it past that, some of them will be commented in the pull request. Now we have additional reviewers assisting, or they might get caught by gates in the actual PR blocking via status check. 92% of risks that go through this process are resolved before production. And maybe most importantly, if you apply your security processes using Git, you don't need pipelines, which means you can scan 100% of your source code from day one. Now, we have 100% developer adoption here. That's because they can't turn this off, okay? I would love to say 100% of developers love Arnica, but I did meet one that didn't, just the one. But I think these numbers kind of speak for themselves. So thank you for sitting through this. Thank you for anybody who skipped lunch. My gosh, I hope that's nobody. But I'm happy to take any questions or have continued discussions following this. Thank you.